Here we go.
It's a Google Sheet. You can find out. She didn't. She's like, oh, you can do something else that's like an Amazon.
All right, let's go to the new stuff. Here we are. We just finished quiz 3. We're on week 12. Let me scroll down. You with me? You ready for this? Here's the surprise. I'm scrolling down. Look at week 14. We have a lecture on the 14th, which will be our last lecture. On the 16th is exam part 1. At 2 o'clock on Wednesday the 16th, which would usually be your last lecture, is going to be the first part of the exam. About 1/3 or maybe 40% of the exam will be on that day. Then Monday, 5 days later, April 21st at 3 p.m. will be the rest of the exam, which will be about 60%, maybe 65 or so percent of the exam will be on that second day. All right, everybody get that? And what a weird time, 3 o'clock, not 2 o'clock on that Monday the 21st.
How long?
What?
What is the first part?
The first part, week 14, Monday and Wednesday is class, but Wednesday won't be class. Wednesday will be the beginning of the final exam. 14th, Monday the 14th will be your final lecture. So today is your last of 5 lectures. You have 5 lectures left today, which is right here up here at week 12 on the 31st. Then Wednesday. Next week, Monday, Wednesday. Week after that, Monday's your last lecture. Now I want to go to announcements. I put some important part in here. I'm sure some of you saw it, but I don't know if everybody looked at it. I'm going to keep changing this. I'm going to take it from 5 more lectures, and it will say 4 more lectures after today. But notice I put Monday, April 14th as last day to hand in late items. There's too many zeros. Go back. Some of you, I don't think even realize you have a zero. It's like you forgot that you forgot to hand it in or something. Go back and look at your grades and see if you have a 0 on anything, because you have all the way until you have about 2 weeks or a little over 2 weeks to get it in. And you can still get, even if it's like 6 weeks old, you can still get a 40 out of 100. And the answer is posted, so there's no reason not to get a 40. You've got to make sure the answer's in your own handwriting, unless it's an Excel spreadsheet, then you can hand in an Excel spreadsheet. Then Wednesday the 16th, exam at 2 o'clock, part 1. Monday, April 21st, exam part 2 at 3 o'clock. So everybody knows what's going on, right? There's our 5 lectures right there, then 2 meetings for exams, and that's it. We're out of here. Anybody take a summer class, spring and summer? Really, that many of you are crazy? Wow. Wow. Now listen, the reason I took a spring class because, I want to graduate as quickly as I can. I want to get out there. I want to start making money. Is that your same reason? Is that your reason for most of you? You want to graduate as soon as you can and get out there and make money? Wow. If I look back in life, college is so much more fun. And even though I was poor, and I was a lot poorer than you were, I look back and wish I would have stayed in college a little longer. So skip spring and summer. Take it off. And go an extra semester. Who cares? All right, go ahead. What was your question? Did I record that?
So is April 16th going to be the material we're working on now, and April 21st going to be with it?
Okay, yeah, here's the deal. Good question. Are you ready? It's like 35 to 40% of the final exam is the new material starting today to that last lecture. The rest of the exam is from the most important parts of the semester. You know there's going to be, for example, a confidence interval question where you're showing me doing the confidence interval from weeks 1, 2, and 3. You know there's going to be a 1 sample hypothesis testing question from weeks 4, 5, 6, 6. And you know there's going to be 2 sample hypothesis questions from weeks 7, 8, 9, and 10. Because those were the most important parts of it, of the semester. And then this stuff that we're learning now from this week to the end will be. Here's the deal, another thing I almost forgot to mention. See that last lecture on the 14th? Whatever I lecture on that last lecture on Monday, April 14th, cannot be on the first part of the exam. It has to be on the second part. Everybody hear that? So on that last lecture, you aren't going to be examined on that information 2 days later. The first part of the exam can be on anything before that last lecture, though. And whatever was in that last lecture will most likely be on the second part of the exam, a week later from that lecture. So that's to be fair.
How much time do you do this?
You know what? I haven't written it yet. If I had to estimate, I would say part one's gonna be about 45 minutes and part two's gonna be about 60 minutes.
Is that just more?
Yeah, more questions. Well, part one will be just like quiz, you know, two was 40 minutes or 45 minutes, so about 6 or 8 questions, I think, right? How many questions were on this quiz we just took? 8, so around 7 or 8 questions, 6 or 8 questions, somewhere in there on the first part. Second part's gonna be more like 8 or 10 questions. Does that make sense?
There's a mix of multiple choice.
Mix of multiple choice and, problems. Like, yeah, just, you guys could almost write the final. You know, you should be able to read my mind and know what's gonna be on the final, because you can see how I wrote quiz 1, you can see how I wrote quiz 2, you can see how it's directly related to the homework and the in-class assignments. You can see how, I already told you how several of the multiple choice are gonna be where you're reading problems, and you gotta tell me which equation you use, which is be a key way to prepare for this and for the problems as well as many of the multiple choices, is just start taking all the homework problems, cut them all up with no answers, and put them in a hat and draw them out one at a time, and see if you can figure out exactly which equation you used on it, and then figure out if you're right or wrong. That's how I prepare.
Are you able to provide us with the answer key for quizzes as reference?
Answer key for your quiz? You weren't writing down your answers? I never hand out the answer key. You know what, this is my last semester though, because I always save the answer key because even though I change the quizzes and final exam every single semester, there's similarities to the previous semesters, but it'd be like reading a homework problem. So I will consider it because this is my last semester, so I don't see the harm in giving away the answers now.
Thank you for the.
Right, is that true? I mean,
So,
future students will never need them because there are no future students.
so to prepare for the final exam, like go over the quizzes in class and the homework.
Here's the thing, the reason you would go over the quizzes for the final exam is because it will kind of help you determine what most likely will not be on the final. For example, on the quiz 3, there was a problem where they were related samples, right?
Yeah.
And you had to solve it using critical value approach. The final exam, if I put a related sample question, it probably won't be critical value approach. It will be confidence interval or p-value instead. So if you're using the quizzes as any way to prepare for the final, it would be, okay, he's probably not gonna repeat this approach because he already had it on quiz 2 or quiz 3 for that kind of problem.
So you said homework is probably the homework in classes.
Homework and in-class assignments, being able to recognize what kind of problem it is you know you're gonna pass the final exam if you can recognize any problem. If you can recognize any problem and know what equation to use, it's impossible to not pass.
Why is it not split between 2 days? Like, why are we just doing it all?
There's 2 reasons why. I found that students do better when I split it between 2 days compared to taking it all at one time. I find there's less temptation to cheat because there's so little time, they're too focused on their own to have time to look around. And number 3 is, I can get them graded in time without that pressure of getting them done, because we have to hand in grades. The other classes finals on Friday, and grades have to be handed in 2 days later, or 3 days later, and there's no way I could get all the grades done in time, and I'd have to stay up all night, and then I'd be sick for a week. So, there's all kinds of reasons.
So go over.
Believe it or not, most students, after they take it in 2 parts, are appreciative they took it in 2 parts. Oh my God, I almost forgot. Is that no, that's the other class. Did anybody, I think sitting around this area for the quiz 3, forget their flash drive? There's one flash drive, I can't figure it out. There's nothing on the flash drive to tell me whose it is, but you can tell they were a student who took quiz 3. Nobody lost their flash drive? All I need you to do is tell me what it looks like. Came from the other class, you think? Maybe sitting around this area. I think I pulled it out of one of these machines right here. All right, well, check if you have your flash drive from the quiz. If you use one, check and make sure you still have it. Yeah, that's my question to you. No, I don't think it's blue. There is something very distinctive about it though, that if somebody lost it, they would easily be able to tell me something about it, because it's very different than most. I'm colorblind, but that's not blue. All right, so, where are we? We're on the new stuff. Here it is, week 12 instructions. Look at the homework. Written assignment, Excel 1 assignment, Excel 2 assignment. Oh my God, what's going on? This is our second to last homework assignment. How much, tell me how, now don't forget, each homework assignment before now, we've had I think 8 or 9 before now. I think it was 9. If you took less than an hour, you owed me time. So has anybody added up how much time you owe me altogether at this point? What?
Because that takes time.
Because if this takes longer than an hour, you have no right to complain. But I don't think it will. It might, just because it's a little tedious, but most of the instructions you need to do these Excels is coming on Wednesday. So if you feel like this Excel part of the homework is gonna be challenging, be here for Wednesdays, or at least watch the recording for Wednesday's lecture, because that lecture is specifically related to these Excels. The written part of it we're gonna talk about today. These are due, let's see, Monday, April 7th, before 2 p.m. like usual. There's the PowerPoint pages, there's the textbook pages and so on, and spreadsheets and stuff like that. Let me go over here, let me go here. I have I wanna point out something that's posted that you definitely wanna have ready. This right here, this document that says week 12 calculation details PowerPoint slides 9 through 11. This document's a good document to have because we're learning two approaches for today's lecture. This correlation coefficient lecture, we're learning two approaches, the p-value approach and the critical value approach, and that demonstrates both approaches. So that's why I wanted to point it out. We're not doing the confidence interval approach for correlation coefficient. So you only have to learn two approaches here, but they're all kind of the same thing. Look at this equation. I put it in words for you. We'll go over it. Hang on, let me get there. Okay. Here's the assignments. Let's talk about them for a minute. Homework assignment is one problem. That's all it is. I'm giving you the hypothesis. You don't even have to try to figure that out. I'm literally giving it to you. Please tell me, is it one tail or two tail from what you see? Very good. I'm giving you the number of observations. I'm giving you the correlation coefficient. All you gotta do is show your calculation details to calculate the test statistic. Give the Excel equation, define the p-value and or critical value. Then explain if you can or cannot reject the null hypothesis using 5% significance and both approaches, p-value and critical value. There's only one problem, but you're doing it twice. You're showing me that you can solve it both approaches, okay? Both approaches happen to use the test statistic anyway, so the only thing you gotta do is solve the test statistic once and then use both approaches after that. P-value and critical value. So you're gonna have two Excel equations. That's all there is there. Look, I'll scroll down, nothing left. That's it. One problem, that's all it is. Let's go to the first Excel. Whoop, not that one. Whoop. This Excel is finding the correlation coefficient and doing some other little things with that correlation coefficient. And here's your variables, here's your X, here is Y. Let me explain real quick what correlation coefficient means. It means, are these two variables related to each other? Are they correlated in some way? Could they be having an effect on each other? Is there something similar about them? As one goes up, does the other one go down? Or as the other one goes up, does the other one go up also at the same way? Or as they both go down at the same time? That's correlation, the direction in which the variables change compared to the other variable over each period. So you look, we have 1, 2, 3, we have several periods there. That's what correlation is. The other Excel spreadsheet is where you're given some variables. X is gonna be the number of months, the 15 months worth of data, and Y is gonna be sales for each one of those months. And you're gonna look to see if there's, you're gonna calculate a slope and an intercept, and then use that information to predict future sales. This is very important. By the way, this regression analysis, I wanna tell you, any accounting majors here? Wow, there's several of you studying accounting. I used this in the real world in accounting as the business manager or corporate controller or the different accounting positions I held than any other thing I learned in school. Because when you get to the point that you're running a business office, you're the head of accounting, you have to do forecasting. You're forecasting budgets for the next 5 years. Even small businesses are forecasting budgets for at least 3 years. So when you're doing forecasts, in order to come up with your forecasting numbers, this regression is like one of the best techniques to use. So and you have to constantly, every month, most large corporations that I'm working for, you update the forecast, your budget forecast every month. In order to do that, turn off. In order to do that, you reevaluate the regression. You get a new slope, you get a new intercept, and do new forecasts. But it's a real useful tool, so that's what we're gonna learn on Wednesday. Let's get into it. We're starting with correlation coefficient. This is some hypothetical data you're looking at. Just pretend you see all of it, but really all you see is at the top and at the bottom. See the dot, dot, dot? There are how many? 26 cities there, but you only see 3 of them. This is what I should have did for that last question on the quiz, by the way. Dot, dot, dot. There was supposed to be like 12 times safe 1 and safe 2. I only had 3 of them there and forgot the dot. But anyway, here it is. The first column is debt payments. What the average amount people are paying for debt payments in each of the cities. The second column over here is income, and this is the average income in thousands, per month. So this is the average income per month. Yeah, I gotta stare at it for a minute because it looks low. Is this in hundreds or something? In thousands? I don't know. The income doesn't make sense. I believe income differences, I don't know if that's in hundreds or somewhere, it doesn't say down there, but it's gotta be in hundreds, right? Or in thousands or whatever. And then unemployment rate for each of the city. We're trying to say, hey, is there a relationship between them? And what we're gonna evaluate is if there's a relationship between what the average monthly debt payment is to the average monthly income. Is there a relationship between them? Now, let's talk about relationships. All correlation coefficients are between +1 and -1. I'm going to throw some examples out there. Ready? -0.22, 0.76, 0.81, -0.77. Every number I'm showing you is between 1 and -1. And the reason I take a number line and I curve it is because the closer to -1 and the closer to +1, the stronger the correlation is. And the closer the negatives are to 0 and the closer the positives are to 0, the weaker the correlation. 0 means there's absolutely no correlation whatsoever, that there's no relationship that can be found. But almost every data has some kind of relationship, but it could be really weak or it could be strong. Now here's the deal. In the area of medium, this medium area, you can't make the determination whether that correlation is significant or not. Is it really telling us that it's related or not related? So you have to do hypothesis testing to determine if the correlation is significant or not. And the basis of determining whether it's significant or not is that sample size. Let's just use a correlation of, let's say, 0.48. I'm going to throw it up here. 0.48. Now, when you think about it, 0.48 on this number line, I don't know, let me throw some numbers in here. Weak. Let me think. I'm just going to make this right here, I'm going to make this 0.25 plus and minus. Over here's the -0.25, and there's the +0.25. Anything below 0.25 is kind of considered weak, but it's not necessarily weak depending on how big the sample is. It could be significant, but in general it's called weak. Let me put up here, this would be 0.75, this one would be -0.75. Anything above 0.75 and -0.75 is usually considered pretty strong correlation. Usually considered strong. And even if I didn't do this hypothesis test here, get the test statistic, by the way, this equals, I should have put that there, equals test statistic T. This is a T we're calculating, not a Z, a T. So everything's the same once we get to T. Once you get a correlation that's strong, let's say 0.88, you may not even need to calculate this because 0.88 is such a strong correlation. But if the sample size is only like 5, you still gotta calculate it, because it could have been randomness that got it to 0.88 because the sample size was so small. But if the sample size were 30 and you got 0.88, you know it's going to turn out to be a significant correlation then. You get it? The bigger the sample size, the more possibility of a correlation existing if you get a number up there in the medium range or above.
Can you repeat that one more time?
All right? The larger the sample size, the more likely that the correlation is gonna be significant based on all, I don't know what else I said. I said something else then, but I can't remember. All right, so now, how do we calculate, as far as calculate, well, I'm gonna give you the formula. There's the formula for correlation coefficient, but I'm not gonna ask you to calculate it. I'm gonna be giving you the correlation coefficient. Either I'm literally giving you the correlation coefficient in words, or I'm giving you an output from Excel that will include the correlation coefficient in it. In either case, you're given the correlation coefficient. But that's how it's calculated. It's on slide 5, if anybody's taking notes here. If you were to plot a bunch of data, here's income at the bottom, income for each period, and there's debt payments for each period. For every city, so there should be 20, however many cities we had, I think it was 26 cities, should be 26 dots there. But what I want to note, what I want you to notice is, if I said to you, if you look at this graph, if you think the correlation coefficient is a positive or a negative, you should be able to determine it's positive, and I'll tell you why. If you put a line through the middle of all those dots, it would be angled upward, which is usually what a positive correlation looks like. If you put a line through all those dots and it's angled downward, that's usually what a negative correlation looks like. A positive correlation says, as one number's going up, the other data is also going up. A negative correlation says, as one number's going up, the other number's going down in opposite directions. That's a negative correlation. So let's pretend we went ahead and did the Excel spreadsheet for all of those cities, and we compared, what we compared again? It was debt payments versus income. Calculate and interpret the correlation coefficient for debt payments versus income. Add them all up. We did and by the way, the Excel function to do it is CORREL. Let me do one. This is the homework though. Okay, but you're not doing a correlation coefficient for this homework, so I'm gonna do one here. Let's see if the month periods have a correlation to the sales. Here I go. I'll do it right here. Equals CORR, there it is, CORRELL, parenthesis, I'm going to give where the data is, the first set of data, B6 ... B20, comma. Second set of data, there it is highlighted, D6, D6 ... D20, ending parenthesis. All right. I want you to start figuring out how to put in words what that correlation is, how to put in words to describe it. Would you describe it as strong, medium, or weak? Strong. There you go. Would you describe it as strong positive, strong negative?
Strong positive.
Oh my God, you're on top of this. Oh, this class couldn't get any easier. Oh my. All right, and then we would go from there and take that. Now here we go. How many pieces of data we got? Hang on, we'll look in a minute. Correlation coefficient. This would be 0.94, I'm just rounding, 0.94 times the square root of sample size. How many pieces of data? Not all of them. I see 15 periods there. You do too? So 15 minus 2. Let me make sure you realize this. For correlation coefficient, the degrees of freedom are however many you have minus 2. Not minus 1, minus 2 for correlation coefficient, minus 2. So there's 15 pairs of data, minus 2 is 13, square root 13 times 0.94. There's the numerator. Denominator, you ready? 0.94 times 0.94, you gotta square it. Then you subtract it from 1 after you square it. Then you find the square root. Then you divide it into the numerator. That is your order of operations on that one. Anybody want me to repeat that?
Yes, please.
Here we go. On the denominator, you square that correlation coefficient first. 0.94 times 0.94. Whatever that result is, subtract it from 1. So now, let's say we got 0.85 or something. Subtract from 1, now we're at 0.15. Square root it. Now, whatever that result is, you divide into your numerator. That's your order of operations on that denominator. All right, so let's keep going. Here is how you write the hypothesis for correlation coefficient. I happen to use the abbreviation as correlation coefficient, CORR dot COEF. Greater than equal, less than equal, or equal. The alternative hypothesis would be correlation coefficient less than, greater than, or not equal to. Just like all the other parts we've studied, they're the same. You either have greater than equal to, greater than equal, equal, or you have less than, or less than or equal, or equal. Or alternatives would be not equal to, greater than, or less than. Same as we've been doing the whole semester. The only thing that's different is, by the way, if you want to use this, P, XY. Large P, small xy stands for correlation coefficient between two variables, x and y. Correlation coefficient between two variables. That's what that stands for. Or you just put correlation coefficient. Right? So that's how you write the hypothesis. Here is the formula using variables. Correlation coefficient, Rxy, times the square root, n is the sample size minus 2, over the square root of 1 minus the correlation coefficient squared. All I did was take that and put it in words here. Now, here's the deal. Once you have that correlation coefficient and you're using p-value, you put the test statistic you just calculated there, degrees of freedom, n minus 2. If it's one tail or two tail, get your, drop the negative symbol if it's a negative test statistic, by the way, just because we're using t dist here. The Excel says use t, what is it, dist dot rt, you can use that one. Some of you used it on your quiz even, which is fine, whatever you're most familiar with. And then that will give you your p-value. Then you compare it to your significance, the rules are the same. If your p-value is bigger than your significance, you can't reject. If your p-value is less than your significance, you can reject. What does it mean to reject? If you can't reject, the correlation was not significant. It's too close to 0. If you can reject, your correlation was significant. There's a definite relationship between the two variables. You want to hear that again?
Yes, please.
Okay, you ready? If you can't reject, the correlation coefficient's too close to 0 and is not significant. Maybe your sample size was too small. Whatever the case may be, it's not significant. You cannot claim that these two variables are strongly related in any way. But if you can reject the null hypothesis, then you've proven your correlation coefficient is significant. And there is a relationship between these two variables.
I have a question.
Yes.
So you told us earlier, for example, if there's a correlation and it's medium.
Yeah, let's say 0.48.
0.48, yeah, and then we have one with a sample size of 10 and the other with a sample size of 40.
No, both sample size, the sample size will be the same as how many pairs you have.
No, I'm saying the two different scenarios.
Problems, yeah, oh, okay,
Yeah.
two different problems.
But
But they
one-
both have medium correlations. He's saying one maybe is 0.48 correlation, one's maybe 0.52, let's say. One
So
has,
same correlation, different
oh,
sample size.
okay, they're both turned out to be around 0.48.
Yeah.
But one is sample size 10 and one sample size 40. The 10 may turn out to be not significant because the sample size is so small that 0.48 may have been, by randomness, could have caused it. But the sample size 40 who got a 0.48, that could be very significant correlation because the sample size was so large that it wasn't luck that's telling you about that relationship. They could truly be related.
Okay.
Get it? Everybody hear that? Oh my God, this class is too easy. Oh, I'm gonna miss you guys. Did I record that? Because I was just joking. Darn. All right, here we go. So let's keep solving. That's that sheet I asked you I pointed out. Here's the calculations. 0.8675 is the correlation between debt payments and income. It's given to us on the PowerPoint. There were 26 cities on that list of cities, minus 2, and then 0.8675 squared over here in the denominator. You do all the math on this, the test statistic, and I want to show you on the PowerPoint. Here's the output for Excel. It doesn't look like our output though, but this is like an old Excel output. But look at where it says T equals 8.544. There's the test statistic. I'm showing you on this how it's calculated. There, by using this equation right here. And we get the same answer, 8.54525, slightly just rounding difference is all. 8.55. It's a very high test statistic. Where usually our test statistics are somewhere between 1 and 3. That's very high. Oh, wow, I didn't realize that way. Here's the p-value. T-test, 8.54525, comma, 26 minus 2, right? The degrees of freedom, there's 26 cities. It's a two-tail. Was it a two-tail? Let's assume it's a two-tail. Equals 9.634 E dash 09. That means move the decimal 9 places to the left. 0.0000000009634. Our p-value is almost 0. Let's say we're comparing it to 1%. Do we reject or not reject? Our p-value is almost 0. Significance 1%. Do we reject or not reject? Our p-value is almost 0. Our significance 1%. Since our p-value is less than our significance, we reject. Do I show critical value on here?
What is there?
Oh, I don't show critical value.
What is there?
Let's do critical value. Ready? What's the significance? What did I say the significance was on this problem? 1% did I use? Did I use 1%? So here we go. Equals TINV equals TINV parentheses. What is this, one tail or two tail?
One.
No, it's two tail. Remember, look, we use two tail in here.
Oh, okay.
So two tail, so we put the significance 0.01. We do not double it. Degrees of freedom again? 24. There's 26 cities. Is that right? 24. Let's put that in Excel. Here we go. I don't have one ready. I'll put it right here. Equals TIMV parentheses 0.01 comma 24 parentheses. There we go. 2.79. Our test statistic was 8.55. Is our test statistic inside or outside the critical value? 2.8. Outside. Therefore, we can or cannot reject. Cannot, exactly. Cannot reject. That's it. That's all I got. I have one. How are we doing on time? We're out of time, aren't we? Are we out? What time does this class end?
15.
Oh, we're out of time. Darn. I have one life lesson. Some of you heard it before.